Hello everybody, welcome to my YouTube channel Best IT Solutions, and today I am going to discuss a more important topic of Java, that is what is the internal implementation of HashMap. So this question most probably asked in Java interview, that how HashMap internally works. So the internal implementation of HashMap in Java. In this video we will discuss the details. So first we need to know, before going to the topic internal implementation of HashMap, we need to know what is hashing and what is HashMap. So what is hashing? So hashing is a process of converting an object into an integer value. So hashing is a process through which we can convert an object into an integer value. Integer value helps in indexing and faster searches. This integer value helps in indexing and faster searches. Through this integer value we can get an index value and we can fast search the elements. And what is HashMap? HashMap is a part of the Java collection framework. It uses a technique called hashing. It implements the map interface. It stores the data in the pair of key and value. So HashMap is the part of a Java collection framework. This is this HashMap is a class which implements the map interface, and it uses the technique hashing to store the elements, and it stores the data in a key value pair with the help of put method. There is a method in put. We throw that put method. It stores the data in key and value pair. HashMap contains an array of the nodes. So Hashmap How Works, it contains an array of the nodes, and the nodes is represented as a class, and these nodes are represented as a class. It uses an array and linked list data structure internally for storing key and value. So internally HashMap implements the array and a linked list data structure to storing the key and value. There are 4 fields in HashMap. So in a HashMap there are 4 fields. So this is a representation of node. This is the diagram of a node. That is, node contains 4 fields. First is, it contains a hash code, which is integer int hash. This is the hash code of the key, and another is key and the value and the address of the next node. This is the next, means it contains the next node. So these 4 elements. One is hash code and the key and the value. The hash code is calculated from the key. So the hash code method. So before understanding the internal working of HashMap, you must be aware of hash code and equals method. So what is hash code method and what is equals method? So equals methods and hash code methods, these are defined in the object classes. So equals method, it checks the equality of 2 objects. So this equals method checks the equality of 2 objects. 2 objects are equal or not. Through this equals method we can check. It compares the key whether they are equals or not. So whichever key we want to put, it compares that key whether this key are equal or not. It is a method of the object class. It can be overridden. So this equals method also we can override. If you override the equals method, then it is mandatory to override the hash code method also. So if we are overriding the object class method equals, then it is mandatory to override the hash code method also, because both are linked. The equals method and hash code methods are linked each other. So if we override the equals method, we must be override. It is mandatory to override the hash code method also. So what is hash code? Hash code method of the object class, it returns the memory reference of the object in integer form. So this hash code method returns the integer value of the memory location of the object, in which memory locations has object stored. It returns that memory locations of the object in the integer format. The value received from the method is used as a bucket. So whichever integer value returned from the hash code is used as the bucket number. So in this integer value is used as the bucket number. the bucket number is the address of the element inside the map. So the bucket number is the address of the element inside the map, because the hash code value returns the memory reference of the object. So indirectly the bucket number is the, and this integer form returns. So indirectly this bucket number is the address of the element inside the map. Hash code of null key is 0. So always the hash code of null key, if we try to enter a null key, then the hash code of null key is always 0. So bucket, what is bucket? Bucket is an array of the node is called bucket. So it is this collections of some nodes which makes an array, which this is the bucket. Each node has a data structure like a linked list. So each node, every node in bucket, there are stored some nodes, and each node has a data structure like a linked list, because it contains the key, hash code, and the hash code and the key and the value and the next node details. So bucket is the array of the node is called bucket. Each node has a data structure like a linked list. More than one node can share the same bucket. So in one bucket many number of nodes can be stored. So more than one node can share the same bucket. It may be different in capacity. So the different capacity buckets are there. So there is a bucket is there, and in this is, so we can call this is a bucket, and in this bucket there are many number of nodes are present. So this is a node, this is a node, this is a node. So these are the different nodes are. This is node 1, node 2, node 3. These are the nodes, and each node contain the key and the value and the next node details. So these nodes are is a linked list, and it contains an array. So the internal implementations of the HashMap is, it is a array of linked list, because the linked list are nodes, and the nodes are stored in a array, which makes a bucket. So here in node 0 it is null, and in node 1 the key is 21, the value is 89, and next is the next node detail, because this node is linked to that node. So this is a linked list, and 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 each node is a linked list, and this linked list are stored in a bucket as a array. So insert key value pair in HashMap. So how we are inserting the key value? So we are using the put method to insert the key value in the HashMap. The default size of the HashMap is 16. So the default size of this bucket or the HashMap is 16. 0 to 15 nodes are, these are the index. So this 0, 1, 2, 3, these are the index. So node 1 is index number 1, node 2 is index number 2. So the important thing is in which index going to store this linked list or these nodes. So by default the default size of the HashMap is 16, that is 0 to 15 number of nodes can be stored. This is the index, 0 index to 15 index. And so we can take an example to understand the scenario clearly. Like in the following example, we want to insert three elements in key value pair in the HashMap. So we have created a HashMap here, and through the map object we are inserting the value like Aman and Sani and Ritesh. We are going to insert these three elements. So let's see which index the key value pair will be saved into HashMap. So we want to know then which index this Aman has stored, and in which index is going to store the Sani, and which index is going to store the Ritesh. When we call the put method, then it calculates the hash code of the key. First, when we call this method and we are going to store, first it calculates the hash code of this key. Here the key is Aman and the value is 19. So now it is going to first it will calculate the hash code of the key. And suppose the hash code of Aman through that hash code methods. Through the hash code method of object class, it will calculate the hash code. So the hash code of the key is, suppose it is 2657860, it will automatically generate inside the Java. To store the key in memory, we have to calculate the index. Okay, now we got the hash code. Now in which index we are going to store this key and value and hash code, that need to be calculated first. So after getting this key hash code, how we can get the index number? So there is a formula to calculate the index number. Index minimizes the size of the array. The formula for calculating the index is, this formula is index number equal to hash code of key and n minus 1. N is the size of this array or size of the bucket. So hash code of the key, we have calculated already. The hash code is this. So the hash code of the key and n minus 1. N is the size of the bucket or array. So here in this scenario, we have already calculated the index hash code is of Aman is 2657860, and is there n is a bitwise operator. It calculates only the lower bits of contains 1. So the size of the default size of the HashMap or bucket is 16. So 16 minus 1 equal to 15, and 2657860 and bitwise 15 equal to 4. So this 4 is the index number. Now this Aman key will stored in index number 4. So this is how this AND operators works here, bitwise operator. Like first, when we are calculating the index number through an method, the method is index for. Through this index for method, the index will be calculated. So this is the starting method. So how? So static int index, because you return a int value. The int value is the index number. So it's a static int index for and int h, int length. H is the hash code, and the length minus 1. Length is the length is, we need to pass these two things. One is length of the bucket and the hash code, and then return it h, and bitwise operator. H is the hash code and bitwise operator length minus 1, because there is a bitwise operator expression executes between the hash code and the length of the bucket minus 1. Expression h and length minus 1 does a bitwise and on h using length minus 1. So this and operator operates within this h and length minus 1, which is like a bit mask to return only the low order bits of h. So it will return only the low order bits of h, thereby making for a super fast variant of h modulus length. So it will calculate in this way. So it does a bitwise and with a number consisting of all ones. That is, bitwise operator means it calculated the all ones. This 1 1 1 0 1 0. Practically reading only the n lowest bits of the hash, which is the same as doing h mod 2 to the power n. So it will be same as the practically how it will done. It will be calculate the lowest n lowest bits of the hash, which is same as doing. We can manually do in this way that h is the hash code mod 2 to the power n. So in the 2 to the power n means the size of the bucket. So in this way we can calculate. So this calculation is internally done by the JVM. Yes, for example, if the hash code is this one, the binary bits, and it is 1000 decimal, and length L equal to this one. So L minus 1 is this one, and H and the bitwise operator L minus 1, because and so the AND bitwise operator operates between this operand and L minus 1 means this operand, and the result will be this one, 488 decimal, which is resulted in the 1000 bit mod 512. So this decimal format, this is 1000. So this H mod 512, 2 to the power n means 2 to the power n, the number of bucket 2 to the power 16. So 2 to the 16 is 512. So the result is 1000 mod modular division. This is simply modular division 512, and the result will come. So now this for the Aman key will stored in the index number 4. The value 4 is the computed index value where the key and value will store in HashMap. Okay. In this way, if we put another value, and this value also going to calculate the hash code, and from hash code we calculate the index number, and it will going to store in another index. And if there is chances of some cases hash collisions. And if hash collision means if two keys have the same index number, if the Aman key has the index number 4, and if we calculate in another index number of another key, if when it will come the same index number, that is it will return the 4, then what happens? This is called hash collision. There is a chance of hash collision also. So this is the case when the calculated index value is the same for two or more keys. Let's calculate the hash code for another key Sunny. Suppose the hash code for Sunny is 63281940. So the hash code is different, but to store the key in the memory, we have to calculate the index by using the index formula 6328. So this hash code is different and the Aman hash code is different, but also it may comes that the index number is same. So the Sunny key index number is also comes 4. So now this key value also going to store this index 4. How it occurs? So it is occurred, the value 4 is the computed index value where the key will be stored in HashMap. In this case, equals method check that both keys are equal or not. So in this case, what happened? The equal method checks that if the both keys are the previous key and now we are going to insert that key same or not. And if the keys are same, just it will replace that key. If keys are same, and the equal method return that the key is same, replace the value with the current value. So key will be same, so simply it will replace the previous value to the current value. Suppose the key is Aman and the previous value is 19, and if we will try to put the Aman same key but value is now 25, so it will replace this 19 to 25 simply. Otherwise, if the key is different, but here the key is different, that is the key is Sunny. So otherwise, here the equals method returns false. So what happened? It connects this node object to the existing node object through the linked list. So it will connect this previous node to the current node through the linked list format. Hence both keys will store in at index 4. So here now both keys, previously this Aman has stored in index 4. Now what happened? This Sunny node has also linked to the previous existing node. That is the next. Now the Aman node next will store the reference of the Sunny key address. So in this way, both the nodes are now going to store in the index number 4, and they are linked each other through a linked list. Similarly, we will store the key Ritesh. Suppose the hash code for the key is, suppose the hash code for the Ritesh is 2349873. The index will calculate, the index value will be 1. And this key will be sorted at index number 1, stored at index number 1. So if the index number is 1 written from that methods, now this Ritesh key will going to store in index number 1. So this is these 4 things contains a node, that is the hash code and the key and the value and the null. That is the next node information. So since here is no next node, then it is null. And here the index number 4 already Aman has stored, and we are storing in Sunny key also here. So these two are linked each other as a linked list. So in this way, HashMap internally works. And through put method we are inserting the value in the HashMap, and through get method we can fetch the value. Like get method is used to get the value by its key. If we pass the key in the get method, we can get the value. It will not fetch the value if you don't know the key. So if you don't know the key, you cannot fetch the value, because if you pass the key as arguments in the get method, it will return the value of that key. when get key method is called, it calculates the hash code of the key, and it will checks the where that key is stored, and it will return the value of that key. Suppose you have to fetch the key amount, the following method will be called. So if we want to search for key amount, then map.get new key amount. So now this amount key will going to search in the HashMap. So it generates the hash code and now calculate the index value of the hash code. Now it will then it will calculate the, in the same process will follow. Input method, which process, this get method, same process follow. First it will calculate the hash code, then it will going to calculate the index value from that hash code in the index formula. The index value will be 4. As we have calculated above .get method, search for the index value 4. It compares the first element key with the given key. So now it is going to, after getting the index value 4, since index 4, there are two elements are stored, two nodes are there. So it will now going to compare the key of the node, key of the given node. So if both keys are equal, then it returns the value, else check for the next element. So if the keys are same, then it will return the value, otherwise it is searched on the next node of the element, next element of the node. If it exists, in our scenario it is found as the first element of the node and returns the value 19. Simply the common value is 19, so it will return the value 19. If the key has not matched, then it will search in the elements in the next node of the linked list. And same way, let's fetch another key Sunny. The hash code of the key Sunny is this one, 632814940, and the calculated index value is 4. As we have calculated the put methods, go to index 4 of the array and compare the first element's key with the given key. It also compares keys. In our scenario, the given key is the second element. So, and the next of the node is null. So, in the next node is null. It compares the second element key with the specified key and returns the value 29. It returns null if the next node of the node is null. So if there is no next node and key also not matched, then it is going to return the it returns null. If there is no next node and also the key has not matched, then it will return null. Otherwise return the value. Since it is matched here 29, since here it is matched the key in the next node and it will return the value 29. So thank you guys, this much in this video tutorial. So this is all about the internal implementations of the HashMap, how get method and put method works, details discussed here. And if you get some knowledge from this video, you can like, share and subscribe this channel.